Start. There we go. Hey, welcome everybody to Astronomy Daily Live. It's 2 hours UTC, and it's time again to get together and chit-chat for just a little while about all things astronomy and space and science and crazy things like that. So hope everybody's doing well. All is well here. Got a really nice monsoon storm this afternoon. Dumped about 5 feet of water in about 3 seconds or so, just like that. So it was that is the monsoon. So that's how all that goes. Yeah, so hope everybody else is doing well. It's actually looking pretty nice. You can sort of see a little bit of sunlight on me still, so hasn't quite set quite yet. So I'm gonna pop over to the chat here, make sure that all the shenanigans are going on that should be. Excellent. So howdy, Tom. Hey, nice to see you there. Uncle Bill, painting the chat yellow as usual. Andy, nice to see ya. So this is just a fun, casual get together. We grab our consumables of choice, whatever that might be. I sort of prefer this amazing molecule here, and I've got well over a mole, maybe even 2 moles of this stuff. So it's absolutely great, and at least at the moment, plentiful. So cheers to that.
Cheers.
And on the panel for the first time ever, Deep Sky Dude. Hey, what's going on? How are you?
How y'all doing, man? It's I've been watching this for a long time, so it's kind of awesome to be here. Thank you for having me.
Yeah, absolutely great. So I see some guitars in the background there. Very good. Yeah.
Just a few, yeah.
Excellent.
That's half of my collection. I think the rest are like over here.
Oh my god!
Actually,
cool.
Not getting touched all too much. So yeah, I love guitars though.
Yeah. Well, some of us get that sickness. Some of us get the telescope sickness. Somehow I've sort of avoided them both. I've got 2 guitars. I've got an acoustic here, and I've got an electric. It's a fake telly. So it's one of those Squire tellies.
Yeah.
I picked it up at an auction. It sounds really good. It's actually got a pretty decent sound. So all right, well, cool. And of course, on the panel, back from the trenches, Atta.
Trenches is right. I need to learn photography to get this revolution imager to work right. I mean, it's nothing like Deep Sky Dude and Carolina and you guys do. It isn't anything like that. But I have never done any kind of photography before other than the one size fits all, point it and push the button. That I don't know from gain and folk and exposure times. I don't know anything about this. So this imager, which I've got all set up, and I do like it. I mean, I got it to work, but without any intelligence. I was just trying stuff until I could see something. It's pretty decent. I'm using it just so I can view what I'm looking at on a screen. Mm-hmm. I really am not into it for photography. I appreciate its resolution limitations. But so far, at my level of knowledge, you just can't, I can't beat what I see out of a good eyepiece. Mm-hmm. I mean, there is no question whether I like putting the contact lenses on because I have an astigmatism. So I have to fool my telescope into thinking I don't have one. Right. So I put contacts in, I correct it. And, I go to all that trouble, but the things that I see through the eyepiece, I still have to say, at this point, are a good bit more satisfying than I see on that screen.
Yeah, and I think once you actually get that thing to work,
Yeah.
I think you're going to be pleasantly surprised. Like I said, the images aren't going to be really, really, really great, but I think that you're going to be really, really impressed because you're going to be, doing those longer exposures.
Well, I've
Um,
seen images people have done, and
mhm.
this isn't by people who are selling the imager. These are people who bought it,
Yeah.
and they sent in pics of what they saw, and I'd be happy with half that good, to tell you the truth. But I'm not giving up. I will learn this. I don't give up.
Yeah, no, and there's no
I don't give up.
reason. Yeah, there's no reason why you should. I mean,
I'm not giving up.
you're
I
smart.
can do
You're
this.
you're committed. You're stubborn.
Indeed.
And
Truly.
I mean, what I always sort of rest on with a lot of things, it's like if somebody else can do it,
I can do it.
probably
Yeah.
can do it. Probably. So and that goes for anything, right? So yeah.
Well, I
So
bought all the accessories for it because I like everything put together really neat, and I got the stands and the hands-free stuff. Well, it turns out I got a chance to talk to Mike Fowler on the telephone. He works for Orange County. He works in Orange County. You know him. He does videos.
it rings a bell.
Deep
Rings a
Sky
bell.
shaking his head. He does a lot of videos demonstrating equipment and stuff. Well, I couldn't resist this. I had to put Mike on. He's from California. And I said, "You're Mike Fowler?" "Yeah." I said, "You're the guy in the movies on YouTube?" and he's really getting off on this. I said, "Oh my God." I said, this is like talking to and you're from California?" I said, "Did you ever do any other movies?" This guy was buying every word of it.
Oh.
I felt that I gave him the one thing he has wanted all of his life, a fan.
Okay.
He now has a fan. But
Good.
he's an amateur astronomer, got a job working at this place. He loves what he does. I mean, I consider him a lucky man. He is working for a living, doing his hobby, basically. I mean, he has to do
not work at
sales
all.
and stuff like that. No, it's not. It's like he's on vacation 24 hours a day.
Mm-hmm.
But it was fun. I mean, I never broke character. I was his fan the whole conversation. Oh gosh, I met Mike Fowler. Wait till I tell my friends.
Well, good. It gave him a good day, and you thoroughly enjoyed yourself. So
I did. I hope he doesn't see this. Ooh, I forgot. This is being recorded. Oh,
I'm gonna send it to him just because you said that.
Well,
oh.
there you go. It's over. No more fan. All right. Well, cool. So, Deep Sky Dude, where are you? I forget.
Usually planet Earth, most times. Sometimes I find myself off. No, I'm in Texas.
Texas, that's right.
Down, like 100 miles or so east of Houston. So if I sneeze the wrong way, I hit Louisiana, basically, or the Gulf of Mexico. It's like, it's 50-50, really.
Gotcha.
And yeah, we're just a small little town out here. We actually discovered oil here in Beaumont, Texas, which is like 10 miles north. Yeah, and I'm actually from a little town called Port Arthur, which is where Janis Joplin is from. ZZ Top, like the musical list of people from here is insane. So, but yeah, just down here in Texas, it's been kind of rainy and stuff because of Tropical Storm Barry going in over, in Louisiana and stuff.
Yeah.
We were very lucky. We got about 2 inches of rain, I think, total. So.
Yeah. I know that area. I used to work for Conoco, not directly for them, but I did patent work with them when Conoco existed. I don't even know if they still exist. And I had
around. Yeah, there's all around me is nothing but oil production and refineries. Yeah, my wife works at Valero, which is I think the biggest or one of the bigger out here.
Oh yeah.
So it's a very oil and industry rich area as far as that goes.
Oh yeah.
Yeah. I think, yeah, once, I forget exactly when it was. It was probably 2006, 2007. I visited um, uh, uh, oh, Johnson Space Center there.
Oh, yes.
And so got a really, really, really good whiff of the air, and you decided it's like, wow, that's pretty potent, at least
Yeah.
sometimes. So
Yeah, it can be. I'm very happy the EPA exists. Let's just say that. Because if they didn't, nor would we probably. This place would
No.
probably be a ghost town, and everyone would be driving in from Houston or whatever just to get to work. It would
wow.
probably be unlivable. There is days where stuff goes wrong out there, and it's you breathe in a little bit heavier air, stuff like that. But it doesn't really do well for astronomy either. There's a particular place out there that creates clouds, and I'm not even joking. The uplift of the only thing I can, maybe I'm wrong about this, but the uplift of their heat causes moisture to condense above them, which causes this train of clouds.
You're
And
right.
depending on which way the
Absolutely right.
wind blows, I'll be like, okay, I'm going to look at, Saturn for an hour and a half, and then just, it comes in. It's like, and not a cloud in the sky otherwise, really.
Wow.
So it
Wow.
can affect that. But we're, the Gulf of Mexico, it's like, there's a saying in Texas, if you don't like the weather, wait a minute, and so if you think you have a clear sky that night, you might get surprised, and that's just the way it goes.
Yeah. Well, hopefully it goes the other way too, right? So
yeah, no, exactly. Yeah. You can, like on a night like tonight, when today looked like utter garbage all day, once that the solar energy radiates out and that high cirrus kind of burns off, I mean, you can get clear, dry night out of nowhere. But then the next night is 100% humidity mixed with 90% Zika or malaria. Just take your pick. It depends on which night.
Yeah. Wow. All right. Well, cool. I'm gonna look in the chat again, really, really quick, see what's going on there. So I guess what we could do. Atta mentioned to me a few days ago that that I don't really look at enough instrumentation. Right? I
didn't say it that way.
I don't really look at enough of that. So what I thought, we could look at the IRIS spacecraft a little bit more carefully. I found, well, one sort of sad picture that's actually up on the NASA website, and then I found a paper that has schematics and some data, so we can do some instrumentation looky here just for a little while.
Awesome.
So yeah, that's one of the cool things about a live stream. It's like, just do whatever, right? It's astronomy, it's cool space stuff. So all right, I think what I'm going to do is I'm going to share my screen. Like that. I'm going to go to infinity. Woo-hoo. And so probably what I should do is I should start with this terrible image. Now, this is up on the NASA website. This is like the official photo of at least the telescope part. And come on, guys, it's blurry. It's a really, really terrible shot. But what you got here is the telescope itself. So this is a 19 centimeter diameter scope. So it's pretty much the same size as the scope behind me. It's got a little bit of a longer focal length, and we'll sort of look at all that too. But I can't they find a slightly better picture? It's like, oh, come on. So, but there it is. That's what it really looks like. All the wires and everything else. I'm not quite sure if there's any kind of protective covering they put on these things. Sometimes they use like a gold foil or something like that. I'm not exactly sure if they covered this up or not, but so it's got the main scope. It's got a finder scope, right? Got a finder scope. So pretty cool anyway. Even though the picture is just absolutely terrible, and you can sort of get an idea of the scale, right? Here supposedly is like part of somebody's hand and their arm here. So you can see that it's it's not small, but it's not really all that large either. And of course, this is going around the Earth. It's a sun synchronous type of a thing, so it's always looking at the sun. But yeah, well, here's the site, and even this is pretty terrible. I mean, a pretty bad schematic here. Extremely low res. I don't know what they're doing. Anyway, the telescope itself is here. The spectrograph is behind the telescope. That's why they have to have a slit right in the main mirror, to let that light pass through and go back to the spectrometer over here. But we'll look at a better diagram of this. I just wanted to show you this. Here's sort of the orbit of this thing. So it's almost a north-south thing, and that's how it stays pointing at the sun all the time, or almost all the time at least.
What optical design is it?
I think it is a Cassegrain.
Okay.
That's what it's saying right there, at least.
Yeah, there it is.
Let me zoom in here a little bit more so we can really see this. So this is from a paper that was published back in 2014, and here I'll just give you the title. It's called the Interface Region Imaging Spectrograph, and here's the list of authors. There's a couple there. So from it's like mostly Lockheed Martin. So yeah, it's just all the people who worked on it, had a hand, I guess, in writing this. But it's a pretty good paper here. I agree, completely fascinating. So like what we were looking at yesterday, you can see all the images here and all that. You can see this black line right here. That's the slit that actually feeds the spectrograph. So as you go down, you can sort of see the spectra that are produced. So I think these are, let's see, what are these? Strong lines over here are carbon-2 lines. And I guess there's is that a chlorine, Cl? Yeah, chlorine 1, oxygen 1, and carbon 1. I guess that's these. I know it's hard to see. Here are the silicon 4 lines. Here are the magnesium lines. It's a double line, in fact. There's a K side and an H side, as they call it. And then there's some structures inside of that as well. But this is all solar spectrum here, all this stuff. It's not noise or anything. That's the real deal. It's the real deal. Let's see if yeah. See, so this is sort of the idea is that they put the slit on the sun, and then that light actually feeds with the spectrographs. So what you're seeing here is a spectrum of like this brightish blob right here. It's probably this part right about here. And you can see, there's even light here, where there is no sun. You're still getting stuff, and that's sort of reflected there. And you can see, that it is definitely in the ultraviolet. 2796 angstroms. That's pretty ultraviolet. 1400, definitely ultraviolet.
That's interesting because it kind of reminds me of hydrogen alpha a little bit.
Yeah, well,
look of it anyway. Yeah.
Yeah, it's just a different spectral line. That's all it is. The sun shoots this light out in all kinds of wavelengths, and it just so happens that these are at least a few of the ones that are seen and observed and extremely interesting, apparently. So anyway, so we can scroll down here a little bit. So here's the whole thing without the panels and with the panels. So this is sort of what it looks like. What it looks like now, right, with all the panels and whatnot. It's not really showing all of the details here. This looks like the X-band transceiver, I would think, or at least the antenna part. Here's the scope. Here's the spectrograph. Here's the electronics box. Cool stuff. When it's deployed, of course, they just have a little covering left over there. So pretty nice. Here's some. I think there's some numbers. Some numbers somewhere here. It's a nice long paper, 53 pages long. So
wow,
some nice light reading. So let's see. It's got a diameter of 19 centimeters and a focal length of 6.895 meters.
That's a long focal length.
That is a long focal length. Let's see. That's 689.5 centimeters divided by 19. So that's like F36.
Wow. Yeah, that's a Cassegrain, right?
Yeah. Yeah.
Those Cassegrains love those F30 some odds,
Yep. Well, and it's a very, very narrow field of view here too. It's like 3 arc minutes on a side. So it's just tiny as well. But they are in space, so they don't have any of the problems in terms of atmosphere, blurring up things or anything like that. So your pixel scale and resolution here is small as well. So that's cool. Here's all the spectral information. This is just the sort of the narrowest spectral band you can deal with. So I think we're dealing with, there are 2 modes here, and I forget exactly what these are, but you're looking at like 26 milliangstroms per pixel. So not too bad. Let's see, in terms of detectors, you've got four of these bad boys on there. Readout cameras, full well of the detector. This is 150,000 electrons. That's pretty typical for CCDs. They're, each pixel is sort of like an electron bucket. And when it gets full over that number, it starts to, act in really, really weird ways. The electrons, sort of spill out the sides, and it becomes really, really nasty. But that's a pretty decent dynamic range there. So that's pretty nice. There's some exposure times. Nice. During the computers, you can actually go and see exactly what kind of computer that is. I've never heard of that one. Might be interesting to look that up at some point. This I thought was really, really amazing, that the total amount of power is 300 watts. So, that's like 3 bright light bulbs. It's pretty amazing. It's what this whole thing runs on. It doesn't weigh all that much either. A couple hundred K. It's not all that much. Not really. And yeah, they are packing in the data here. 20 gigabytes per day.
Wow.
Of data, and that's nothing, right?
Yeah.
Soon that is going to be just like this tiny drop in the bucket.
I just ordered from Amazon a 400 gigabyte mini SD card. I have it somewhere.
Oh my gosh.
$45. Thanks, Amazon. But can you imagine? I mean, 400 gigabytes on one. I mean, this thing is thinner than a postage stamp. It seems.
Yeah. Yeah. Well, that's only going to get more and more and more like that. I don't think that is going away anytime soon.
Agreed. Yeah.
Whatsoever. I am old enough to remember 10 megabyte hard drives. You heard me correctly. Megabyte hard drives.
Look, when I first started working at the University of Arizona back in the late 80s or so, we were just absolutely thrilled at the idea of spending $1 per megabyte. We thought that was just like the most cheapest thing we'd ever heard in our lives, right? And of course, a terabyte is 1,000,000 megabytes. So that would have cost us $1 million back then, right? So, I mean, we were absolutely thrilled. It was $1 a megabyte. What are we going to do with all of that? I don't know. So, yeah, it's come a long way, and we ain't seen nothing yet.
Well, I haven't worked in that industry, but as fast as, for example, storage capacity went up exponentially in about a 2-decade period. And I couldn't help but ask myself, did they already have some of this technology in the wings and they were just releasing it piecemeal? I mean, it was continuing to be developed. I realized that. I worked on some of the patents. But I think, I don't know, some of that might have been marketing decisions.
There was some kind of a breakthrough, sort of, I don't know, late 80s, early 90s, in terms of being able to etch on the nanoscale, and I think that's probably what really broke it was us figuring out how to etch really, really, really small structures, and that happened somewhere in the early 90s, and yeah, from then it's just exploded. So I don't know if it's beginning to slow down now a little bit. I don't know. It doesn't seem so, but I think they've hit a brick wall again. But yeah, I don't really pay attention to much of that either. So I'm not really sure. Not entirely sure. Oh yeah, here's another nice schematic actually showing the inside.
Very cool.
Now,
that's awesome.
Yeah. Now this is called a conceptual design. So you know, you sort of, this is a cartoon, right? Don't you know, this is not exactly how it looks. This has been colored. This has been prettied up a lot. But you know, it shows you all the main, you know, components and whatnot in here, and you can see the spectrographs in the back with all of its gizmos and mirrors and crazy stuff. Here's you know, the telescope part with that long focal length. Here's a not quite. I'm not quite sure if the optical path. I guess.
Yeah, it's in orange there, right? It goes primary, secondary into the spectrograph through the mirror, right?
Yeah, but there's got to be a camera that is imaging off the primary mirror. We have to get real pictures out of this thing. I'm not quite sure where that is.
Maybe they're splitting the light, and one's going to the spectrograph, one's going, like, they got a split prism or something.
Yeah, I think you might be right.
It's pretty ingenious design, though.
Inside here, well, yeah, you know, most spectrographs are. They're well. Here is a spectrograph. So here it's coming in from the scope, and then it's just, you know, it's going all over the place.
There's their split prism, and you can see they've got the gratings right there.
Yeah,
that's pretty smart stuff, man.
Brilliant, absolutely brilliant. Yeah, you gotta, you know, try to pack all these optics into these really small spaces, and it can be done for sure. But yeah, pretty amazing. Really hard to follow the path here.
Yeah, that's I'm struggling here.
Yeah, and you know, I'm not seeing. Okay, so here are all the cameras over here. Okay, so everything else is either a mirror or a shutter or some kind of a filter.
Wow.
So yeah. Maybe pack it in there. And I think that's pretty much it. You know, they get into a lot of the details here, but I don't think there's much more here. As I said, you know, really light reading. You know,
Cosmic, how do you think that they keep something like that collimated? You know, it's hard enough for us, like Dobsonian dudes, to keep our Dobs collimated when we wheel it out to the driveway. You know, we're not launching this thing on the back of a bomb. You know, I wonder if they have servos or if it's just so rigid. Like, how are they doing that?
Yeah. You know, that's a good question. And this paper, I would say might at least be able to point you in the right direction. Because yeah, that's a good question. Of course, you know, they've got to just tie that thing down like crazy, right? Just, I mean, really tighten the bolts down, and I'm thinking though that you know, once they're up in orbit, they're going to go through a bunch of calibrations. So you know, even if they can't necessarily do anything, you know, to fix any kind of misalignment, when they can know about those kinds of things, sometimes you can sort of, you know, counteract, deal with those kinds of things. But yeah, what that kind of process is, yeah.
Give it any volume control.
I just turned myself up a little bit.
So you turned yourself up. Okay, good.
Yeah. That's fascinating, man.
I have no control whatsoever.
All right. No, deep
you used to could. There was a little applet in here. I remember back in the good old days of YouTube doing this. You know, there was a little thing, and no more though. He's right. It's gone.
That went away a couple of months ago. It was just gone. So that's all right. You know, we all evolve. So you know, to a certain extent, beggars can't be choosers. So you know, it's absolutely. I mean, I think it's absolutely fantastic. You know, that we can do this at all, right?
Absolutely.
So you know, the fact that, you know, we still can, cool, very, very cool. So, all right, well, I'm gonna look at the chat here, make sure that everything is going well.
Everyone appears to be
Cool.
behaving, I guess.
Yeah, well, you know, I just don't like that. I want to see some
Get into some mischief there,
misbehavior,
Astronomy Daily Live fans. What are y'all doing?
mischief and stuff.
Boy,
Absolutely.
you just can't please some people, I'll tell you.
All right. Well, look, I'm already going into crisis mode, so I think
no.
I'm going to jump into an object of the day, and we'll take a look at that, maybe sort of briefly today, and then we can sort of let it spill over into the next day or so if we want. So let's just do another NGC object, the new general catalog. So there's 7,840 of those in the entire sky. Most of them are galaxies or little faint fuzzy things that nobody pays attention to. But you know, if you think about it, right? If you were to observe one of those every single night, 7,840, that would take you like 21 years or so.
Forget it.
And that's just the NGC objects. That's nothing.
Yeah.
It's absolutely nothing. I mean, in one Hubble Deep Field, there are, you know, 10,000 of these things.
What do you mean nothing? That's longer than the rest of my life.
Well, I gotta say, you just gotta change your plans.
Yeah.
Change your plans. You gotta hang around.
And you know, one good thing about it though, some of the NGCs are close enough where you can get 2 in one shot. So there is that.
Okay,
yes.
so there's hope. All right.
That is true. That is true. That is true. And I am committed that we're going to look at every single one of them.
Let's do it. I'm on board.
Yeah. All right. So I'm going to let Nightbot randomly choose for us. Or should I go over to random.org? Why don't we do random.org? We haven't done that in a while. Nightbot is you know, behaving itself. But I used to go over to random.org and do it over there instead. So I'm going to set that up, and let's do it over there instead this time. I don't know why, but I just sort of like that better. I don't know. Wow, I'm gonna get some whiplash off of that.
Engage. Oh wait, you're supposed to say that before. Sorry.
Oh well. I'm no good at that either.
I was late.
I was early.
I will never be a captain. Okay, so there are 7,800 here. I'm going to zoom in here a little bit. 7,840. So it's going to choose an integer between 1 and 7,840. Now, you know, the NGCs are sort of ordered by right ascension. So the small ones are going to be around 0 hours, 1 hour, 2 hours. And the larger ones are going to be around 23, 22, and sort of get a bit of a gauge on where this object is in the sky. Now, I don't know if any other catalogs do that. You know, the Messier doesn't. Right?
No. Here.
My guess is that probably a lot of the catalogs do, but well, this is one of them. So, all right, I'm going to push the button. Here we go.
Here we
Bam. 3263.
One of my favorites.
Yes. Yes. 3263. So that's sort of right in between. 3263 divided by 7840 times 24. So that's almost 10 hours in right ascension. So let's see how close it actually is. This could be in the north. It could be in the south. We just won't know until we go over to
spoiler alert.
Sinbad here. Sinbad, and spoiling is okay because you know we're
this is a good
way
one.
too laid back here. So all right, 3263. It's probably a galaxy.
Bingo.
It's probably a galaxy. Most objects are.
Most galaxies are galaxies. That's right. That's what I've heard.
Well, got to do this.
It's a dim one though. This one you might be pushing it telescopically.
All right.
Negative absolute mag negative 21.5.
Hey.
That doesn't seem right. It should be positive. I'm looking at a
you are looking
website.
At the absolute magnitude.
Yeah, that's right.
Which let me back up a little bit. In terms of galaxies, that's a really, really, really weird concept, right? Because the idea of the absolute magnitude is what the brightness of this object would be if it were 10 parsecs away.
Oh.
So how do you put this galaxy to within 10 parsecs of us? How exactly do you do that?
You need a really big rope.
There's absolutely no way, because this galaxy would be inside of our galaxy. And that just doesn't make any sense at all. So, you know, what that magnitude scale shows more than anything else is luminosity. It's sort of, you know, how bright it actually is. But okay, so you know the right ascension, 1029. So that matches, you know, the number pretty good. Looks like it's more or less a southern object, though. It's got a declination of negative 44. So don't know if you know this or not, but if and let me make sure I'm doing this exactly right. Yeah. So if you take your latitude and add see, how does that work? Yeah. Take 90 degrees and subtract your latitude, you will get a number. And if you negate that number, that is your lowest declination that you can see in the sky. So where I am at a latitude of 32 degrees north, the declination of my southern point is negative 58 degrees. So you can sort of get an idea there as to what your lowest is. So theoretically, I can see this here from southeastern Arizona, but at maximum, right, it's going to be about 14 degrees above the horizon. So I'm not going to try.
Yeah, it's going to be pretty low, huh?
Yeah. Looks like it is moving at a pretty good clip, about 3,000 kilometers per second, moving away from us radially. So it's got that motion, and then it has, you know, some motion in the sky as well. But because it's so far away, we really can't see it, you know, moving much in terms of right ascension and declination. We just sort of see, you know, this radial motion, but it's moving along at a pretty good clip. That's you know, like across the United States in a second.
Yeah, it says the Sky Safari Pro says 1% the speed of light, which is pretty interesting.
Oh yeah, that's right. Yep. You know, the speed of light is 300,000 kilometers a second. So yeah, that's that.
Their math checks out. That's pretty awesome stuff. It says visually, it says it's an 11th magnitude spiral, so this would easily be doable in probably a 16-inch telescope, maybe, if you're a visual person.
Yeah, you know, I'm thinking with a dark sky, and at least Sinbad here is sort of reporting around 11-ish or so. Yeah, you'll be able to see that in the 10-inch scope. You'll have to use your imagination a little bit. It is definitely not going to look like this. You'll sort of see, this small region right there. It is going to look like a very, very, very faint, fuzzy thing. But, I think at least a 10-inch, definitely a 12 or a 14 or a 16 for sure. It's definitely longer here than it is wide. It's a nice, angled spiral there. It's definitely a spiral. All right, well, let's take a look at a few of these. This looks like the Digital Sky Survey picture.
Looks like it's got a nice little tidal tail. It may have been an interaction in the past there, which I guess it would be an ARP galaxy maybe if it was a little bit more north. I don't know if Houghton ARP went that far south, or maybe he deduced that this wasn't an interacting galaxy. That's interesting stuff, though.
Yeah, I'm not quite sure where he was observing from, but yeah, that's pretty low. So
yeah, it's really low.
Yeah, looks like it might have a friend right next door. It's kind of hard to tell, if these are, next to each other, or if one is very much in front of. But yeah, there's definitely some action here, for sure. Well, that bodes well in terms of it being studied. Some of these poor objects, nobody's ever looked at, with any kind of instrumentation or anything at all, and that's always a bummer. I feel, sad for them, because they're just being ignored. So, and I just don't like it. Okay, so here's another.
Looks like that's a pretty galaxy-rich area from Sky Safari Pro. What I'm seeing there is, it looks like there's a bunch of neighbors.
I'm sort of thinking that this might be sort of the southern extent of the Virgo cluster.
Oh.
That whole area there, that goes from Big Dipper,
Coma Berenices, Virgo, right?
Down through Coma, through Virgo into Leo. This I think is pretty far south of Leo, but there's just tons of galaxies over there, tons and tons and tons.
Well, like you said earlier, you can pick any patch of the sky you want to, take a long enough picture, like the Hubble Deep Field, and you just start counting.
Yeah. That's why I say there is more stuff out there than we can possibly imagine. So let's quit fighting over these little things here on Earth and get out there a little bit where there's all this stuff, right? We don't have to fight anymore about things, at least. We won't have to worry about it anymore. So yeah, this guy sort of stands out here. He's a pretty large spiral. Looks like these guys are also. Wow. There's a lot of distorted galaxies here.
Interacting stuff, which is interesting.
Yeah. So this guy looks like he's in a little bit of trouble there too. So
now, is it an artifact of the image? I'm not familiar much with Sinbad, but is it shifted blue because like kind of the stars are too? There's like maybe a filter over it that shifts stuff into the blue, or is that what we're seeing there?
This is the Digital Sky Survey. So my understanding of that is that they basically have red and blue that they've combined. I think we can just look at the red, and of course that's going to be a grayscale, but that is the red light. And I think there's a DSS2 blue. Maybe. Well, maybe not. Sometimes there is, sometimes, oh yeah. So here.
Uncle has some good stellarium shots of these.
Oh, good. Good. Post them over on the Discord if you want, Uncle Bill.
Yeah.
Okay, good. Excellent. So if you look at the blue, you'll see probably that these guys are much brighter. Yeah. So, yeah, I think this is just the combination of the two. So, you know, I'm not exactly sure if these colors are real color, true color as they call it. I would call it a false color.
Okay.
But, you know, these are definitely leaning towards the blue, right? For sure. Whether they're actually that blue, probably not.
Especially the one we were looking at earlier, you know, as it was receding from us, so it would appear more red, right? I mean, even in the visual, they kind of lean that way, it would seem.
Yeah, it's, you know, and probably when you look at the spectral lines of these things, you can definitely see a redshift. You know, to really see that kind of a redshift, they have to be moving really fast, which usually means, you know, they're really far away. At least that's what the theory is at the moment. So yeah, you know, the fact that, you know, we are seeing this still relatively blue, like I said, it's a little bit of false color there.
Yeah.
I would say. Yeah.
To your eye, this thing is going to be like a gray, smudgy nothing. I think it's
right. I mean, you're going to see
7x1 arc minutes, or 8x2. Sorry.
Yeah, and that's this whole thing, right?
Yeah.
You're not going to see any of that. You're going to see this little tiny part right in here. It's going to look like a fuzzy star, and, you know, you're going to have to use your imagination a little bit. You know, stick your tongue out, you know, on the left, and you know, maybe see it, right? So pretty faint, but all right, well, cool. Let's spend a couple of minutes just going through a little bit more of this. So yeah, it's got a bunch of different names, of course, different catalogs and whatnot. Okay. I don't know if I've ever seen HDC before. I don't know what that is. But it's all right. This live stream is about questions, not about answers. I have no answers at all, but I have tons of questions.
Me too. Same exact thing, man. But I think by asking each other questions, we all get a little bit smarter. So that's a good thing.
Yeah. Well, you know, I don't like to rely on you know, the what do you call them? You know, the sort of the high priests, you know, the scientists who you know, we go and ask questions and they give us answers. It's like, you know, these are just people just like us, and they're as confused as we are.
Yep.
Right. So they don't really have any answers. They are giving you, you know, what the current understandings of things are, and they make it sound like they have an answer, but nobody has an answer. And I certainly don't. I just have lots of questions. All right, let's get a distance measurement here based on the velocities. Whoop, I got to do this one. I would think that this guy is pretty far away. So 40 million parsecs away. So a megaparsec is 3.26 million light years. And then I'm going to multiply that by 40.83 in this case. So that's 133 million light years away. So yeah, that's a pretty decent distance. You know, the fact that we can see some structure in it means that it's not like insanely far away. But yeah, that's a nice distance. and 133. I'm trying to remember. And Deep Sky Dude or somebody in the chat, you know how far away like the Virgo cluster is on average?
Yeah,
I think it's around 100
I
or
think
so.
the Virgo well, it depends on which galaxy. Like most of them I think are in the 50 million, I think.
Okay.
But
Yeah.
again,
So
that's a fault in me. That's my default. Like if we're at an outreach event and I'm showing a galaxy, if somebody asks me, it's always 50 million or whatever. So
let's look for Messier 87.
That's kind of the center, yeah.
Is sort of the so-called center, yeah.
Which, by the way, is a beautiful in a massive 36-inch Dobsonian telescope. Larry Mitchell, a buddy of mine, owns one of those, and we could actually see the jet coming out of the core. So that was pretty ridiculous.
By eye.
Visually, without averted vision, looking directly at it, you could see the jet coming out of the ball. It was easy, man. But at 36-inch aperture, you know.
Yep, light bucket.
Yep.
Yeah.
36-inch Dobsonian. What's he do? Move it with a truck?
A trailer. Yeah.
Trailer? Yeah.
And a team of people.
Yep. All right, so cool. So it's looking like this thing is pretty much right where Deep Sky Dude said it was, 53.5 million light years away. So, so this galaxy, 3263, is 3 times further away.
And I'm getting a size. This is Sky Safari Pro, but it's saying 300.8 thousand light years diameter, or 92 kiloparsecs. So maybe you can break that down for us.
Yeah, that's really, really big.
That's huge. That's a monster.
Yeah, that's about 3 times the size of the Milky Way.
Wow.
Or so. Now, you know, if we wanted to get into a little bit of simple math, we could actually take the size that they have it here, that number, and the distance. We could actually calculate, you know, the size.
Oh, interesting. I didn't know. Yeah, I didn't know how that was done. Actually, that's very cool.
Yeah. Maybe we should do that at some point. I like to show a little bit of mathematics here once in a while. So, anyway, yeah, that's a pretty far out galaxy there for sure. Pretty good agreement in terms of velocities. There's been some measurements. Some of these are redshifts, and some of them are velocities. These supposedly you can relate these two things if you use, you know, the Hubble constant. Right? So, all right, let's look at these references here. So there's only 45 of them. So, you know, despite it being what looks like a pretty interesting object there with a little tidal tail or whatever it is, hasn't been studied all that much. So let's
fascinating.
Absolutely. So all right, let's take a look here. Nothing too recent.
So these are papers that have been written about this particular galaxy?
These are papers that supposedly reference this object in some way. Now, it doesn't have to be, you know, this paper is, you know, specifically about this galaxy. It could just be, you know,
talked about, I guess, or
yeah, you know, or mentioned in a list, or and sometimes they aren't mentioned at all. so
I like the name of that one right there: Attack of the Flying Snakes.
Attack of the Flying Snakes.
Formation of isolated H1 clouds by fragmentation of long streams.
Right. Well, we're gonna have to look at that.
Yeah, man. I'm just gonna read that whole thing tonight.
That is clickbait if I ever saw it.
Yeah.
So
bravo, writers of that one. Bravo.
Yeah. You know, sometimes you know, Peer review lets those kinds of things go because it's either really, really cool or, somehow it's relevant, right? So,
Yeah, absolutely. It breaks up the monotony of some of this stuff too, I guess.
Oh, God. Tell me. Okay, so this was back in 2016 in the monthly notices of the Royal Astronomical Society. All right, so existence of long H1 streams and small free-floating clouds is well known. Okay.
Now, is that hydrogen 1? I mean,
hydrogen 1, yeah.
Which is
hydrogen
just another
1.
flavor of hydrogen, I guess?
That is neutral hydrogen. So that has 1 proton and 1 electron. Yep. So, well, what I always like to do first in these kinds of things is sort of go to the pictures and see what's going on there. There's lots of references here you can see.
That's funny. Up there, I caught it said the missing satellite, and when we were looking at the images, I'm like, there's a tidal tail, but there's nothing over there. Like on M51, for instance, there's a clear galaxy that's pulling that, right? But there's nothing on this one. I was like, wow, there it is right there.
The missing satellite problem is a discrepancy between the number of galaxies detected in the local group and the number of predicted cold dark matter simulations.
Ooh.
So this is how it goes, right? You have a simulation, you have some kind of a guess, and you've got a bunch of buttons and knobs on these things, and you turn them, and it doesn't match what you're observing. Yeah. So it's like wow. But that's how it goes. That's at least part of the scientific process. Mm-hmm. And at least here we like that. So let's see if there's any, specifically what I should do is look for this object, because that's the whole point here. 3263. Let's just see if I can do a 3263. Is it going to come up? Okay, so Vela, which is a supernova remnant, I thought.
The Vela Nebula is. Yeah, the Vela is the constellation, I believe, that this thing is in, I think.
That makes sense. Substructures which run perpendicular to and are offset from the disk of NGC 3263. Given that the nearby spiral galaxies show clear signs of disturbance, it's much more likely that this is a tidal debris than a dark galaxy. Okay, interesting.
Huh.
That's the only mention of that galaxy in this whole paper.
So I guess in this particular paper, they're studying one nearby, and we're just using it as a like, hey, this is another one or something.
Yeah, I think that's right. I think that's a valid interpretation there. Let's see if there's any. Wow, this is a big paper too. 46 pages. It's just
more light reading.
It's unbelievable. I don't know why there's a blank page here. That's a little weird. Look at that. It's okay. Well, it's Appendix C. So there's lots of appendices. There's lots of wiggly lines here. Wow. I'm not even going to try. It looks like it's some kind of time scale. Time in millions of years.
Jeez.
Detected mass. I'm not exactly sure what they're looking at here, though. So, wiggly lines. Who cares, really?
It looks like art, though, so that's kind of neat, right? They look good in a gallery.
There you go. But yeah, I mean, being able to understand this fully, of course, you got to read all of this. You got to go through it all. This red thing looks like maybe some kind of an average So detected mass. Yeah, I'm not quite sure what all those are. I'll keep moving here.
More science
So
art.
Yeah, so this is the evolution of an isolated cloud. Apparently. All right.
Oh, here we go.
I wonder if these are some simulated images. Yeah, so these are some
cool.
simulated images. Final timestamp, 5 billion years. With what, a 4 billion solar mass stream, I guess they're calling it. Yeah. Huh. Okay.
So different models being interacted with, like the galaxies, I guess, after they pass through each other, is different models, huh? Interesting.
Yeah. Again, it's the thing where we really have to dive into it to really.
Yeah, but it's fun to just kind of scratch the surface of these things sometimes and just see, kind of. I'm a pretty pictures guy, right? So I like this kind of stuff.
I am too. Yeah. Yeah. And I mean, what I'll do, right, is I'll start to look at these, and then I'll start reading the whole thing, because I want to know what is going on in all of there. I don't have a clue, but so curiosity is a crazy thing. So yeah, this is kind of interesting. It's a little weird looking. It looks like somebody was taking a long exposure in a telescope and bumped the telescope.
Yeah. There's a number 9 right there. I mean, just right there.
There's a number 9 right there. Yeah. So not quite sure exactly what is going on here, except I guess these are supposed to be, like some tidal streams after some kind of doing an interaction of some sort. So don't really know. Don't want to be too specific about anything because I don't have a clue.
We have a Steve Olson just joined us.
Steve Olson?
Yeah.
Hey.
Hi, Steve.
Howdy, Steve. Nice to have you here. So we're doing astronomy. We are looking at a paper that is talking about an object of the day, which is NGC 3263. It's a galaxy, I guess, down in the constellation of Vela. So nice to have you here, Steve. Great to have you here. So actually, and we're almost at the end. I start this at 2 hours UTC, and I'd like to go for about an hour or so. We're a little bit over because, well, that's just how it goes. But we're looking at some simulated data showing some galaxies that are going through some interesting motions here. Some kind of tidal interactions of some sort. Don't really know much about it at all. I'm not here to give any answers. Not at all. All right, let's like I said, I think this object is going to sort of spill over into tomorrow's live stream too. So there's your flying snakes, Deep Sky Dude, for sure. Yeah.
That's exactly what I came for tonight. Flying snakes.
Flying snakes. Can't get it anywhere else. Haha.
Nowhere.
Yeah, I think I'm looking at the time. Let's hang it up for today. But I want to pick this up again because there's a few more things in here. It looks like, well, yeah, maybe not a supernova in that galaxy, but for some reason, the galaxy of the day might have been mentioned in these. Don't really know why. Maybe we'll look at one of these and see what's going on. But in the meantime, I think I'm going to get out of here for now. So I'm going to check the chat really, really, really quick. The Neuralink presentation. All right, very, very cool. That's Musk is doing some pretty interesting things, and yeah, I think it's great. I think it's great. So keep up with him. Doing some amazing things. I wish that there were more like him. Yeah, I guess you just have to be at the right place at the right time. So, all right.
Yep. Start PayPal, and then you can play with rockets, I guess.
There you go. All right. Well, there goes Ata. She's gonna be turning into a pumpkin here, and I think I'm pretty much going to do exactly the same thing. So for now, I'm going to get out of here. Peace, cheers, and all that. Live long and prosper. I will be back here again tomorrow, 2 hours UTC. Make sure to subscribe if you haven't. Hit the thumbs up, hit the bell, spread the word. I'm not really trying to cast any kind of net and trying to capture anybody else. I want this to be sort of a tight knit group who really shares a passion and just likes a fun casual thing where we just sit back and just sort of let loose a little bit, forget about the rest of the world and think about the universe instead. So, all right, everybody, take care. I will see you in a little less than 23 hours. Just one little spin. Hold on to your hats. All right, it's a dizzying trip, but pretty sure that tomorrow will come. So I'll be here again, and I hope you stop by. All right, see you later, everybody. Take care. Bye.